All right, class. We need some more instruction on lesson 5, especially how to write your own code. So 27 of you turned in this exact same code. I mean, this is an example of two people, right? But yeah, there's some spacing issues and everything, but what are the chances of following up this logic and using the same exact variables and everything over and over again, especially 20 sometimes matching perfectly? Stop it. Write your own code. These things are simple. You paid for the class you're supposed to be learning. And then you attempted to use a dictionary, which wasn't even covered yet. And no one even commented it out and explained what it was or how it worked. I've been saying this for how many weeks now? If you use advanced topics, explain what they are and how they work. This saddens me when I see people cheat at this level of code because you could achieve far more complex things with Python and code than these simple instructions that we're given. These simple tests of your critical thinking capabilities. It just proves to me that you're not thinking at all. And I've been teaching this class for a while, and it saddens me. And the amount of cheating goes up every semester and quarter, no matter how I teach, in person, live, fake, recorded, not recorded. More people join and less people join in. If I change how I teach, it doesn't matter. It's sad. The world needs good coders. The world needs critical thinkers. And if you can't use these simple tools and write simple scripts to achieve something simple in this class, how are you going to get a good job and get paid well and do good? You know, there's a problem when code's the same out in the real world and people get paid for it. That's called intellectual property theft, and you'll get shut down, sued, and your business will go under. I mean, that's an extreme, but it will work. That's what happens. Write your own damn code. Just learn this stuff. I make a damn good living using Python and these skills, and basically, you folks are insulting me, and you're hurting yourselves, and you're nowhere near anyone's competition if you can't script your way out of a paper bag. So, and if you think you don't need this stuff, think again. Your large language models, your AI, it could generate code for you, but is it 100%? How are you going to go in and fix it and tailor it if you can't read it? You guys have to think again, or think, then think again. For those of you that are doing your work, good, learn it, because you don't have to worry about the people who are like copying work or cheating as your competition, because frankly, they're not. So let's talk about lesson 5 lab, because I see a lot of confusion already. Let's see what we could do here. Lesson 5 lab was Caesar Cipher, sorta. Basically a replacement tool. And we covered everything we need to be successful, right? Find is pretty much all you need, and a string. No need to get tricky here. No need to build yourself a complex dictionary that we didn't cover yet. No need to get out of hand. There's tons of different ways how to write this. So let's do it. This is the basics of it. I'm going to remove this part. We know we need a decoder and an encoder. All your tools in your arsenal, walk through your lab on your own, complete your own work. Do not use art or char because those are not even mentioned and not even necessary. So I'll just leave that there. That's an example of what we need. I already built a simple variable called alpha. I have a space. I have the lowercase alphabet, uppercase alphabet, and the most common ways to end a statement, either with a period, question, or an exclamation point. You can add all punctuation if you want, but let's just handle those for now. So let's think about this. What do we have to do here? Well, we have to find main, right? That's important. What else we got to do? Let's define a welcome. We'll do that. I always forget to do that on my first one. I don't know why. I'm going to say print, and we'll do a quick welcome here. Welcome to the encode decoder. That's good enough for now. Add a couple returns here. Good enough. Let's see what else we could do. Let's grab a username. Let's define a global, just call it username. And we'll say username equals input. What is your username? User, yeah, we'll do 2, doesn't matter. Username code / tab, boom. And we'll say, you guys are fun here. We can say run equals, now we can make this tricky, right? Input. Let's go, would you like to continue with this program? Right, a question mark. Guide the user, yes / no. And colon / tab. That's a nice input, right? Cool. So what have we got so far? We defined our main function. We didn't dump anything in it yet. We have our welcome. We have our if statement. We're collecting the username. And what are we going to get here? We can get, let's think out logically. How do we want to do this? Well, do you want to encode or decode? So we have their username, so we could do that. And we're going to, let's see. We can, after we do that, we're going to define gather clean encode. Because not only are we encoding, we're also cleaning a message, right? Because what I mean by cleaning is we either have to add dashes, remove dashes, deal with punctuation, all kinds of stuff like that, right? So we have to define clean or gather clean encode. We still have to figure that out, right? But then we also have our define decode. So we got those 2 in place. So we know that we're going to have to decode, we know we're going to have to encode, but before we do that, what do we have to do? Well, first we need to gather the input, right? A couple things we could do. We could write a new function, or we can stay right where we're at, right underneath the username. So now that we gathered the username and we defined our other functions, now we can start adding our logic here. So we have, would you like to continue the program, yes or no? So if run is equal to y, or run equal to lowercase, because it could have edited it, right? So now here's our comparison operator to see if they want to run this. So if run is equal to capital Y or run equal to lowercase y, now we have now we can ask them if they want to encode or decode. Let's see, user while equal input. We could say, let's see if this works. Username. This may not work, but we'll try. We'll test it here in a minute. Would you like to? Now you can do things like this. These are some standard old school console tools. A lot of things for you hackers out there that use Kalilytics. You'll see a lot of console tools with your selections spelled out with brackets around them and already in the sentence that's posted to the screen. And then you clarify it by doing an E/D : /tab, right? Let's see, one input while user. Now we can start to add some more logic here. So we have all this, we're nested, we're tabbed over, and now we could use our use while. So this is where we decide if we're going to encode or decode. So if user while is equal to E, guess what you're going to do? You're going to gather, well, you got to output a message, right? Because your other function is going to return something. Out message equals, and this is where we gather, clean, and code. Right? So gather, clean, and code. And then here's your new message, which will be your out message. So print f. Here is your new encoded message. And now you can just put out mess there. Boop. Perfect. Right. Still have to define what gather clean code does, but we'll figure that out. Now, we have our if statement. What if they enter D? Well, elif user while is equal to D. Then we're going to do the same thing. Out message equals gather, clean, decode. And same thing. Print f colon out s. Perfect, right? It's always best to put an else. And we could create a new function called exit. Call it run exit. Just copy this. Let's see. Let's do an import up here. Import this. Let's do run exit. So there's a couple ways that we could exit this. Excuse me. Been sick for weeks trying to get over this thing. I've been doing a lot of traveling too. It's not helping. So now on the run exit, we could simply do a print statement. And we could say you're about to exit shutting down program, right? You are about to exit shutting down program. And now here is where you call your sys.exit. And you can put this goodbye. There we go, perfect. So all that's good to go. We got that. One thing we need is our if main, right? If name is equal to underscore main. And we call it our main function. Pass, run exit. Okay, so if we enter something other than E or D, it should run our exit, right? Should ask us for our name, save. I want to save it as this, so. And, the file names, name them right. You're still having problems doing that. It's ridiculous. You should be way past that at this level. There's no reason where your file name should be something obscure or like Lab 5, something that you'll never remember what it does, or you can't search it. If you don't fill out your header, you can't grep to search for anything, And this purpose, train your minds, baby. Right? So let's save it, hit F5, hit enter to close. Boom. So what happened? What happened? Anybody know what happened? Our main just calls on pass. So when we call down pass, it went all the way down here to hit enter to close, which we won't need anymore, so I could comment that out for now. And we'll remember to get rid of that later. So what does main have to run? Well, it has to run our welcome function. Save, F5. What is your name? It's Tim. Would you like to continue with the program? Yes. Tim, now it's got my variable. Tim, would you like to enter E or D? Now here, encoder decode's not done yet, so I'm going to put X, and we should get our else. You're about to exit, shutting down, system exit, goodbye. So it works as designed so far. Now we have to do the hard stuff, right? Now we have to encode and decode. Let's test this one more time and hit encode. Tim, yes. Encode. Here's your new encoded message, none. Okay, so we said encode, and it just passed this, and this is what it did. So it worked as designed, because right now gather clean code is just set to pass, and it's exactly what it did. So let's define this. So what do we need to do to encode our message? Think about it. It's going to first, we got to tell them, give them some encoding tips, maybe guide them a little bit. Only alpha and common punctuation, right? So let's get rid of this pass and hit enter. We'll do our print statement first with our directions. Man, I'm still a little miffed at how many of you just copied that code. I'm so upset. It's so sad, because like I need good coders at work, and they get paid well. I make a good living doing this stuff. So let's say for encoding, make it a little large so I could see it. Remember to only enter alpha and common punctuation. I always misspell that. Punctuation. Dot, question mark, exclamation point. There we go, right? Does that work? I could say, for example. There we go. Sorry. Okay, cool. So there's our print statement. And now we could start with get our original message. So OG message, OG mess is fine. Equals going to input. And this is where we say, what is the message you'd like to encode? Question mark, right? Slash tab. Okay, so that's going to be stored in OG message. Well, let's think about this. What's going to happen when we get this message? It's going to be a long string. Well, what makes sense? Well, let's turn it into a list. Let's call it a list message. And that equals OG mess. Turn it into a quick list. All you have to do is split it, right? Because it'll split it on spaces. And now I'm going to have a list, but I'm going to copy that. Well, let me think. A list message, got it. OG mess. Let's copy it anyway. Never know when we're going to need it. OG mess. Copy. If we use it, we use it. We don't. I'll come back and delete it. OG mess. Okay, so I created my list and my copy. Not a copy of my list, right? But now we're going to have to output something. Output mess. Well, I'll just call it out mess. And this is just going to be an empty string for now, right? Now we have a copy of the message. So for each letter in copy mess, now if letter in, I think I named it alpha, right? Yeah, all the way up top. If our letter is in alpha, like space through the alphabet and that, it'll come back true. So if this is true, if letter in this list true, I'm going to say new letter equals string, because it's going to return an index, because I'm going to use find. I'm going to use alpha dot find, and I'm going to find what? I'm going to find the letter, which is going to give me back the index it's in. So if I look for the little lowercase a, it'll give me the index of 1, and 1 will go into NL. So that should be it right there. Let me see. Yeah, I got it all closed. Find out letter, and alpha. Okay. Now we're going to take the new letter and we're going to add it to outmess. And we're going to do outmess plus equals itself and do new letter. And this is where we can add our dashes. Plus dash. So new letter really isn't a letter. It's going to be the integer of, it's going to be the indice that find returns. So if it finds lowercase a, it'll be a 1, and this would be 1 added to new outmess with a dash. Cool, right? Or we could do else. And we need something to let us know, print f close. Let's see, we could say exactly what it is. Letter not found. Just some message to let us know for right now. So there's our if else statement. Blah 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 blah. Let's print out pre-cleanup. Now, what I mean by pre-cleanup is we're going to have dashes. We're going to have a dash 0 dash because index 0 is our space. I usually put if I'm doing this, I usually put the space at the beginning or the end or in the 13th spot, just so I remember what indice it is. So let's print. Here is your pre-cleanup. Here is your pre-cleanup message. What we call it, outmess? Yeah, outmess. So let's run this now. Save it, hit F5. Welcome to the decoder. Blah, 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 blah. Let's scroll down here. What's your name? It's Tim. Let's continue. Yes, let's encode. Here's your new encoded message. None. What happened? Let's go back. Blah, 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 blah. Here's your new encoded message. This break here. E. Gather, clean, and code. Oh man, did I put it for decode? I did. That's what I get for not paying attention. Decode. That's the beautiful thing about coding late and tired and angry. Encode. Save F5. Let's do this again. Tim. Yes. Encode. Here we go. Got our directions. What is your message you drink? This rocks. Boom, boom, boom. There we go. Pre-cleanup. This is what I mean by spaces. It's in 0. Then 50-55 is this guy. So now we're going to clean this up. Here's your new encoded message, none. Okay, we're going to go ahead and fix all this, right? Yeah. So we got all this right here. Now we have to finish our cleanup. So let's think about this. Letter not found, print here for messages, cleanup. Let's do pre-message. Let's give ourselves another container. And now let's just use replace. Because now that we know that our space is going to be a -0-, we could remove those. So we could say, what is it? Outmess.replace, calling the replace method. We can call in the string of -0-, replace that with just a space, right? And let's see, what do we want to do with the end of it? Well, let's print the pretty message. We can always delete that. Let's take a look at that. New message. Let's see how far did I get in my head here. Message. Let's see, what do you think? Well, we'll say new message. New message equals pre-message, and we'll strip it because the very last thing would be a space if there's a 0, right? Well, we'll see if this works. We'll start at the beginning. We'll go to -1 just in case. And now we have our new message. I think that should be good. Let me think. Because what we got here is our new out message, right? So print. Out mess. So gather clean code. We'll get out mess. We'll go into out mess. Let me see. Because now we may have to return something, which is no big deal. I'm just thinking in my head if this makes sense. Let's save it, hit F5, let's run it. Tim, yes, encode, this rocks. So it removed the 0 like we planned. Still left this, we'll deal with that. I'm not worried about that. Here's your new encoded message, none. Well, how can we deal with this? Well, we can write another function that looks for the last thing. And if it's any of those numbers of 55, 54, and 53, we could remove it and hold on to it for later. That makes sense? Should make sense, right? But the main thing I want to focus on before we do this whole thing is that you understand that I'm just using one string to do all the encoding and decoding using what we found, using what we learned in the lesson. Find, replace, stored a variable, adding plus into a string, really simple stuff, and it's working, right? We're darn near done. And this part needs to return something. New mess, pre-mess, that's it. Return new mess. Let's see if that works now. Because it shouldn't say none. Let's see. Tim, yes. Encode, this rocks. There we go. So there we go. We're finished cleaned up because it actually did the last part. It removed that dash. So this is looking darn near clean and beautiful, right? We removed our space. It looks like we're encoded. Now, if you want to add a key, where would you add your key? Like you could ask them, would you like to encode with a key? Select between 1 and 10 or 1 and 6 or whatever. And then right here, you leave it as an integer. And the next line is where you'd add your key. You do your math and then turn it to a string. That's simple, right? But we're not going to mess with key right now. So we got our encoding working. Well, what if we want to decode? Well, let's think about what we did. We took a letter, asked it, we found it in the index, right? So now we have to ask the string what's in the index. Let's just take this into the shell. And how do we do that? Well, if I type in alpha, gives you back everything. If I type in alpha with the number in what? Square? If I type in 55, it returns the item. So that's all I have to do to decode. But I have to do it over and over and over. Right? So that sounds like a loop. So let's decode. We're not going to pass anymore. I'm going to grab this whole code I wrote right here. Let's see if I can change it. Right? No sense in doing everything. Print for decoding. Let's see, for decoding, remember to enter the encoded message. Remember to enter the encoded message with dashes. Is that what I want to do? No, I want to do dashes. That's good. I'll buy that. All right. So we can still say OG mess. We can still use this. Instead of what is the message you'd like to encode, what is the message you'd like to decode? That was simple, right? I don't think we have to turn it into a list. I didn't use that list anyway. But we can copy it, so we have our copy, right? Now we're going to copy it. Let's think of this. We have to do things backwards now. Well, that's easy. We're just going to take this and flip-flop it. All right? When you find an empty space, put that. So we're putting back our spaces so we could decode it. That our copy and replace. Now we could split them. But how we're going to split them is we're going to split them on the dash. So pre-mess, out-mess, copy, replace. Now we could just use the same thing. Pre-mess equals pre-mess dot split. But we're going to give it the delimiter of the dash. So it breaks our message up on the dash. It's going to make a list right here. Right? And if we want, we could print the pre-mess just to see it. Excuse me again. Let's see what we have to do here. Once again, we have our out mess. I'm going to get rid of this because this is bothering me. Now it's in my way. So I'm going to create our out message again, equals just empty variable. We're getting ready for a string. And now we have to do, let's think about this, for each item in pre-mess, Oh, yeah, this is easy. So now we say for each item in pre-mess, item equals integer item, because they're going to be strings. So we need to change the item into back to an integer, and then we have to use splitting to get the index. So outmass plus equals itself, right? And we'll call alpha and then just the item, because this will take the new integer and do exactly what we did here to get back the string we need. And that string will then go in outmass and rebuild our message. And let's see. Outmass, print outmass, return outmass. That should be our decode. So let's see if we got this. Decode, 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 outmass, outmass. Let's go decode. So we have this message here. I'm going to go ahead and copy it because that's our final message we received. Save F5. What's your name? It's Tim. Yes, I want to decode this time. That's the message I want to decode. Okay, we got some breaks here, so what did I do wrong, right? Cannot access local variable outmass where it's not associated with the value. Now this gets tricky right here. 69, 18, 86. So where? So which one is the hot one, right? 86, 18, 34, 69. Always go from the bottom up. So let's check out our line 69. What does that look like? Well, that's encode. Did I forget to change it up here? Code. Decode. Start encoding. This is our decode. Let me see this. Let me take a look here. It's like, give me a second. So out message, copy mess. We got that. Oh, right here. Look, look, look. This is my bad right here, I think. Where I put copy out mess is broken right here on 69, because you see how I called on out message before I defined it. Does it have to be out message or does it have to be copy message? It has to be copy message. Copy message replace and the pre-mess split. That should do it. Let's see. Poor man's debugging. Decode. I don't have it copied anymore. I'll grab it. There comes the boop, boop, boop. There we go. Remember we did our print split, and there's our original message perfectly back. So let's walk through that again. Let's clean this up a little bit too. Let's get rid of that last print. We don't need that anymore. So with one string of the alphabet, a space, and 3 of your common punctuation, and we limited that in directions to the user. We defined our main, we called our welcome. Our welcome gives them the welcome to the encoder decoder, defines our global username, grabs the username. Would you like to continue? Yes or no? If yes, would you like to encode or decode? If they choose E, it fires off encode. We'll follow that one first. Encodes tells them more directions, asks them for what they want to encode, creates a list. I don't use the list though, I just use the message itself. Then I copy it We create an empty variable. We say for each letter in my copy message, my string, if letter in alpha, if that's true, grab the indice of it, turn it to a string, and store that in NL. Add NL with a dash to outmess. And then if you find an outmess, if you find a dash 0 dash, replace it with a space, so it removes the spaces and breaks them up into words. Beautiful. Absolutely gorgeous. And this removes the last dash at the end of it. So it leaves the, like if it's 55 or 54, 53, it'll leave the integer, but remove the last dash. So this removes the last dash. And then it returns our new mess. And if you encode new mess goes into out message, and then it prints our out message out. Cool. Let's follow the path for decoding. Welcome, enter username. Would you like to continue? Yes. Would you like to encode or decode? Decode. They type D, it hits decode. Decode tells them to enter their message with dashes. Would you like to enter your message? Or what message would you like to decode? They type in their message, copies it. We replace all spaces with the dash 0, so we could use that later to find the index. And we split it on the dashes, creating a list of integers. Well, they're not integers yet, they're strings. So it's just a list of strings. If we printed this, you just see a list of strings right here. It's create our outmass for each item in my pre-mass item. This is where we turn to an integer. Then we just call on our string with the indice, and that gives us what it is. Add to outmass, return to outmass. When outmass is complete, goes in outmass, we print our message. That's it. Game over. We did it. We encoded, we decoded, we used replaced, find, split, and one long string. Nothing to it but to do it. Simplify your designs. Now, this is different than how I usually solve it. Every time I write this, I write it different, because it's fun, but also keeps it fresh. There's probably 15 different ways we could have solved this. We could use ends with to grab the punctuation. We could use begins with to grab the capitalization. We could have changed it all to lower and simplified our alpha string. There's a lot of different things we could have done to solve this. But my point to you is be creative, have fun. Simplify, simplify. Remember, simple is complex, right? Remember, import this. Beautiful by Tim Peters. Beautiful is better than ugly. Explicit is better than implicit. That means comment your stuff. Simple is better than complex. Complex is better than complicated. You can have a complex, simple solution, and it's not complicated. Flat is better than nested. If you nest more than 2 times, you're doing it wrong. Well, nest more than 3 times. Sometimes you have to, I get that, but usually you don't. Sparse is better than dense. In other words, clustering your code up, give yourself space. You know how I've been give myself a little eye room so it all just looks nice. This, you can tell by just looking at this that this all belongs to welcome. Just be good with your code. Readability counts. That goes up to sparse is better than dense as well. That's about as far as we'll get in this class. This is about intermediate Python. And then we'll do the rest in advanced. But I hope this cleared up some of the nonsense that I've been seeing with using ord and char and all this crazy stuff. dictionaries that you haven't even touched on yet, or you showing me that you mastered a complex object when you haven't shown me that you mastered simple things. This literally is the fundamentals. Master the fundamentals. Take the time. Master the fundamentals. Show me that you've mastered the fundamentals. Because you won't have to learn a lot of complex things if you master the fundamentals. Just saying. Simple is best. But I hope that cleared a bunch of stuff up. That's it. I'm done. I'm tired. You guys hear me? Oh no. We'll see.